Okay, welcome. Thank you very much for coming to the session. My name is Rob Heineman. I'm a program manager on the Failover clustering team in Windows Server 2012. And I'm here to talk about building a highly available failover cluster from the ground up. So in this session, I'll be reviewing the new features that we have in Windows Server 2012. And I'll be showing you how to get started with the failover cluster, some of the things that you have to do, some of those new features in action. So I'll show you how to leverage them, how to build it for yourself. So a few logistics. So it's a lunch session, but please feel free to eat. That's fine. Make yourself comfortable, of course. Let me just ask you guys, as we get started here, how many of you are running SQL Server on a failover cluster? All right, excellent. How many of you are running Hyper-V on a failover cluster? Wow, okay. How many of you are running a file server on a cluster? Okay, excellent. And Exchange Server? Wow, okay, so we have the right people in the room, so that's really good. So let's get started. So the objectives today, I'll be talking first about failover clustering and the infrastructure improvements that we have in Windows Server 2012 and how Hyper-V then uses those as a platform. But SQL Server can also use the same infrastructure as a platform, as can file services, as can Exchange, as can third-party services. So all of the failover clustering platform or infrastructure improvements can be used by the other applications as well. In this presentation, I'll be focusing a lot on Hyper-V, but it's applicable to all the other applications as well. Okay, so has anyone here heard of this thing called the private cloud? Okay, so the private cloud. Our view is that it's composed of 3 layers, right? So failover clustering infrastructure, Hyper-V for the virtualization platform, and then Service Manager or System Center to provide monitoring and management of the bits that are running on the private cloud. So I've talked to a lot of you already. I know that a lot of you are already providing services to your customers. You're either keeping applications highly available, or you're providing services such as VMs or VDI scenario. Actually, how many people are running VDI scenario or interested in VDI scenario? All right, see, it's an increasing number. We'll have some things that are interesting for you guys. So when it comes to providing services for your customers and building a private cloud inside your company, this stack will help you a lot. All right. Now, for me, the great thing about Windows Server 2012 is that you can use these features to build the private cloud and to deliver those services your way, the way you want to do it. We don't dictate storage topologies. We don't tell you what networking topologies you have to use. We don't tell you which vendors you have to work with, right? We don't tell you the policies that you have to run for storage or networking, right? It's all the way you want to do it, right? The way you want to use the bits to deliver value to your customers. So one of the great things about working in Windows Server is about 3 months ago, I was in a room with about this many people, about 400 people. And this was a Plugfest meeting. So on the Redmond campus, we had people coming to us, drive vendors and antivirus vendors, file encryption vendors. They're working with us on the new CSV file system, the new clustered shared volume file system. And that's when I really understood that we're building a big ecosystem here, and that we're enabling third parties to come in and to really add value to the ecosystem. So that was pretty neat. So we had people from all over the world, and that was a pretty intense meeting where We got a lot of things done. Okay. The first thing I want to show you today is the Server Manager. So how many of you have seen the Server Manager already? Okay, lots of you. Let's make this quick. Okay, so many of our customers want to run their servers using the server core. So they don't want a UI on their servers. So here I'm showing you, this is a Windows 8 desktop. And I'm going to show you how I can easily launch using the RSAT tool. I can easily launch the Server Manager and connect from a Windows 8 client machine onto my servers. For some of you, this is important. So for those of you who are interested in running server core, this capability can be pretty good. Okay, so to get started with failover clustering in Hyper-V, first you need to install the roles. So here we go to Manage. There we go. Add roles. Let me just scroll over so you can see that. Add roles and features. Okay. And then this is the familiar dialog. What's interesting about this is that I don't have to do a remote desktop connection to the actual server machine. I can pick this machine handily. It is at the top of the list. And I can just I can start installing roles on this machine directly, remotely. So this allows you to manage your machines even when they're core machines. Okay, so you select the Hyper-V role. It'll prompt you for the features that it needs as well. Then you select failover clustering feature, all of its sub-features, and then hit next. And it's that simple. So it's very easy to install the Hyper-V role, the failover clustering feature, and just to get started. Okay, so that's the Server Manager, and so it's detected here that I'm installing Hyper-V. So it's got a few questions for me about Hyper-V. Yes, I want to enable it to use the NIC. We'll skip the migration feature. We'll take the default paths. Now we can install. So that will install the feature on that server 0. Okay. So, sorry. Let me see if I can get this right. Okay, good. Okay. Cluster validation. So cluster validation is very important, a huge improvement to us. So once you install the features and then you create a cluster, in the first step in creating a cluster is called cluster validation. Since Windows Server 2008, we've had this model where if your cluster can pass validation, then we will support your cluster. So again, your storage topology, your network topology, if it passes validation, we will support it in production. So in Windows Server 2012, validation is 6 times faster. Validation includes built-in the Hyper-V checks, firewall settings, storage checks. So it's completely built in. Actually, let me go ahead and show you what a validation report looks like. So I'm now going to switch over to my other machine here. And if I can remember my password, there we go. Okay, great. Okay, so here we have the Failover Cluster Manager. The Failover Cluster Manager UI has been improved greatly to help management of clusters. Now, the funny thing is, a lot of times you won't even see this UI. A lot of the people that we work with actually create clusters, manage the life cycle of the clusters completely from PowerShell and outside of this UI. But if you have administrators that want to go in and manage the cluster directly with this UI, then that's quite possible. Another big change that we've made with this UI is we enable you to manage all your VMs directly from this UI, and all options that you can do with the Hyper-V Manager, you can do from the Failover Cluster Manager, with the exception of managing the Hyper-V switch. Okay, so I just click on my cluster name, and I can say, view the validation report, and it will find and it will display the latest validation report for me. Now let's have a look at this. This is a single file, an MHT file, and it's designed to be really easy to navigate. So here at the top, I can see the categories of checks that it's made, and it's very easy for me to go down and have a look and see what the issues are. So here I got a warning on my network configuration. So here the validation report is telling me, look, you only have a single network in your cluster, and this is a single point of failure, and the cluster will work, but it's not recommended. So if you have a highly available application, right, you probably want to have multiple networks for redundancy. Okay, so another thing I want to show you is, let me just show you where you find the cluster validation reports. So cluster validation reports can be found in the C Windows cluster report directory. Let me show you. So Windows, cluster, reports. So here you can see all the validation reports that I have. So if we click on the first one, it'll display it. And so here you can see that I had a Hyper-V configuration issue the very first time, at my first attempt of running validation on this machine. So let's click on that and have a look at that. So this threw a warning. It said, hey, look, you have a problem here. These are machines with different network interface cards, so the default Hyper-V switch for the different machines was named differently. And so it gave me this nice warning, and it said, hey, look, you need to go and change the name of the virtual switch so it matches on both machines. And that's what I did. And so that just took a few minutes. So we're really hopeful that the speed improvements and the clarifications that we've made in the validation report will be helpful to you. So another nice thing about these MHT files is they're easy to, since it's a single file, they're easy to transmit, easy to send to your colleagues. It's easy. I have one customer that uses validation reports for documentation. They like to document their cluster configurations. So they're handy. Okay. So let's see if we can do this. All right. Okay. In terms of features, one of the great things about Windows Server 2012 is increased scalability. So a failover cluster can now handle 64 nodes and 4,000 VMs. Many of our customers came to us and said, hey, look, we want to do live migration. We want VM mobility. And increased VM mobility, so live migration, it used to work only within the boundaries of a cluster. So we'll talk about that more later. It's no longer the case. It works now inside and outside of a cluster. But inside, so many customers ask us to keep increasing the capacity of the cluster so that they could achieve greater mobility. And so we've done that. So for those of you who are non-Hyper-V customers, 4,000, the ability to support 4,000 VMs, what that means is it gives you the ability to support 4,000 groups, 4,000 cluster groups, or 4,000 cluster applications. So that's another way to think of it. Okay. Another huge improvement we've made in Windows Server 2012 is clustered shared volumes. So clustered shared volumes, it's a new file system that runs on your cluster. It enables every node in your cluster to see the same files, essentially. So if you have shared storage, we recommend that you use clustered shared volumes. In R2, clustered shared volumes was restricted to Hyper-V usage, but now we're opening it up and we're making it the default file system. We're asking that you consider using it for all of your applications. So particularly with the continuously available scale-out file server, it's a very good combination. So there are many, many CSV improvements in 2012. So first, the first CSV, we have many I/O modes, and then basically the storage stack and network stack work very well together. So if I/O can't be completed by the storage stack, we'll actually use the network stack to complete the I/O. So anytime you have shared storage, this adds greater resiliency. So it'll protect you from a node failure, protect you from a storage card failure, protect you from a network failure. So it gives you that additional resiliency. It's very fast. So it's almost as fast as physical. It's something like 97% physical. Backup has been vastly improved. So for those of you who are running Hyper-V workloads and you have snapshot and backup requirements, our support for backup has been greatly improved. Also, we support multi-subnets, so for those stretch clusters or geo clusters. Tomorrow, my colleague is giving a deep dive session on CSV, and he'll be covering all of the improvements in depth. So there's a special session just for that. Okay. So one piece of feedback that we got from customers was that it was rather difficult there we go. It was rather difficult to add a disk to CSV, but that's something that we've changed. Adding a disk to CSV in Windows Server 2012 is a single-click operation. So here, let me show you. Let me just pick this disk here. This disk is in available storage. I just want to show you that it's a single click. So add to cluster shared volumes, one click, and there you go. It's that easy. So pretty easy demo. Okay. Now, okay. I talked a little bit about the continuously available scale-out file server. This is a new cluster role. It uses CSV underneath. And the core protocol through CSV and up through the continuously available scale-out file server is SMB3. Hyper-V can take advantage of the SMB protocol. So, and SQL Server can take advantage of this role as well. For Hyper-V and SQL Server, this means that they can take advantage of something called transparent failover. So on a scale-out file server, there's a single uniform namespace. So it's very easy to add nodes to your cluster. And then your security settings are just adopted by the new servers that are in there. You don't have to go in and add security settings specifically for the new servers. As requests for file handles come in, we distribute the file handle requests across all of the nodes in the scale-out file cluster. So this means that a particular node won't get hot. In other words, a particular node won't have all of the file handles. When there is a failure of a storage node, we're able to take the file handles and to move them to the surviving nodes. So, and since they're virtual file handles, we do this transparently. That's what the SMB3 protocol enables. So, for example, if you're running a SQL Server workload and you're doing transactional I/O against your database, it means that your storage for the database can fail, and will move the file handle. And so I/O only pauses slightly, and then after a few seconds it resumes at normal volume. So this means that there will be no connection errors. So at least for your storage tier. So there are a number of other usage for the continuously available scale-out file server. We have a lot of interest in this, and a lot of people who are really looking at this for their various workloads. Another advantage of using this for SQL Server, since we have so many SQL Server people here, is using this cluster role. You can get around the drive letter problem that SQL Server, the drive letter limitation. So SQL Server often limits you to 26, 24 drive letters. But using the continuously available scale-out file server, you can use UNC paths, and you can get around that limitation. So basically, you have much greater scale for SQL Server instances. Another advantage that CSV brings you is asymmetric clustering. So on the left-hand side here, we see this is a more traditional configuration where you have a file server cluster and then a Hyper-V cluster on top of it. Many customers were coming to us and saying, you know, this is nice, it works for us, but they wanted the simplicity of being able to collapse and use a single cluster. So many of our customers are finding this to be a popular option. This allows them to manage a single cluster and to scale out in terms of they can add nodes that have storage cards if they want to increase their throughput, their storage throughput, or they can add nodes for compute if they want to increase the throughput for their workloads, for Hyper-V or whatever their workload is. So it sort of gives them that flexibility. Now, CSV enables that because of its ability to do redirection and to manipulate the I/O. It used to be, I know many Hyper-V customers in Windows Server 2008 R2 who don't like this concept of redirected I/O, that they consider it that it's considered a negative thing in 2008 R2. In 2012. It's now, we've improved the problems associated with redirection in CSV. And it's now redirection, it's actually a way of life for some customers who want to run these asymmetric configurations. Another advantage that I want to just point out here, actually this is more germane to CSV in general. CSV has implemented a block cache which enables the file system to share memory on the host system. So we share both L1 and L2 cache. And if you have a read-intensive workload like Hyper-V, especially for the VDI scenario, this can really improve throughput. So, for example, we ran a test in our lab recently, and we were able to cold boot 2,500 VMs in under a minute with the CSV block cache enabled. So we saw a 20 times improvement with that setting. So it's very exciting for those of you who run the VDI scenario, who want to solve that 9 a.m. problem where you have customers coming in and who want to load their desktops right away. Check disk. So who here has had to run check disk in their lives? And how many of you enjoyed it? Okay, so we actually have a little graphing problem here. It's a nice problem to have, actually. The new version of check disk actually runs in under 3 seconds, and it makes it very difficult to graph it correctly. So I hope you'll forgive the graphics, but it's a good problem to have. So the bottom line here is that the check disk algorithm has been greatly improved. So the check disk will continually scan as the disk is being used. It'll continually scan for bad sectors. It'll mark them as it finds them. So when you run the check disk command, then it already knows where the bad sectors are, and it can quickly fix them. So there's no full disk scan anymore, right? That's the big change. So for many customers, adding a disk was a scary thought. And adding a big disk was an especially scary thought. And so we got a lot of feedback on that, and we worked really hard on this algorithm. And now we can't find a disk that's big enough to exceed 3 seconds. So if you have a disk, if you find one, and you can get check disk to run for over 3 seconds, please let me know. I'll buy you a latte. I'll buy you 2. I'm a generous guy. But seriously, it's a big improvement. And the bottom line is that if you use CSV, there's 0 offline time for check disk. CSV will occasionally pause I/O, and it will run check disk for you, and then resume I/O. So check disk is so fast that we can actually do that. We can just periodically pause I/O, run check disk, and repair anything that's incorrect, and then resume. So another great reason to run CSV. Okay, increased security. You can now use BitLocker to encrypt CSV volumes. Many of our customers said, look, we want high availability, we want to run CSV, but we have our cluster in a location that doesn't have the full security of a data center. So we need some additional security enhancements to use it in that scenario. So, for example, if you have a retail outlet that has a point of sale system, that you might not have full data center security there. You might just have the cluster in a closet. You might be worried about someone getting in there and stealing the disks or stealing the entire rack. You might have customer data on that server, and you don't want that stolen. Or you might have a different scenario where you have a cell phone antenna and you have an audit program or something like that running on that cell phone antenna, and you just have a small cluster there, you need security there. So let me show you actually how easy it is to run BitLocker on a disk. So I have a CSV disk here. Here we go. So this is a CSV disk. So cluster disk 17, it's the cluster shared volume 1. So what I can do, and so you can use the manage BDE command. To find the disks that are encrypted and the disks that are not encrypted. So here we can see that we have volume 1 and it's fully decrypted. There are no protectors on there. So let me just get the command for you. So I'm going to use this command. If it works. There we go. Okay. Now, the first time I use this, it's going to give me a warning. And it's going to complain. It's going to say, hey, what are you doing? So it's given me this command. It's complaining because the disk is clustered. So let's go back. What we're going to do is we're just going to take this disk and we're going to put it into maintenance mode. So we're going to turn on maintenance mode for the disk. Maintenance mode is there to streamline administrative tasks. So you can put a node into maintenance mode, which I'll show you in a minute, and you can also put disks into maintenance mode to do operations like BitLocker, for example. So the UI nicely shows me that the disk is in maintenance mode currently, And so when I come back down and rerun this command, then it will start adding that protector. Now, as soon as it does that, I can do other operations on the disk. One thing you should take note of is I've asked it to put on protection and to give me a recovery password. So it's important that when you do this that you take note of the recovery password that BitLocker provides you. That's a critical step. Another important step is that in order for the cluster to use the disk, we have to add a protector. We have to add a protector for the cluster. So let's get the name of the cluster. Let's just get cluster. And then let's go ahead and add a protector for the cluster. So this is an important step. So as it's encrypting that file, that disk, what we're going to do oops. Oh, there it goes. Okay, so what it's just done for me is it's just added the, come on. Okay, so what it's just done for me there is it's just added the protector for the cluster. So the cluster SID has been added as a protector in there, and now the cluster can use the encrypted volume. If you're doing live migration of VMs between clusters, of course, you have to add the SID for the other cluster as well. So the other cluster can use the BitLocker volume. Okay. Well, actually, let me go back and show you one thing. So we can also ask for the status of the disk as it's running. So okay. So apparently I haven't made enough sacrifices to the demo gods. There we go. Let's have a look. So, okay, so at this point it's fully encrypted. So that was very fast. Let's go back, and then we'll take that volume and we'll put it into, we'll turn off maintenance mode on that volume. It'll go offline just temporarily for a moment there before it's brought back online for us. There we go. Okay. BitLocker. Okay. Next, let's talk about storage spaces. Who here has heard about storage spaces? Okay, a lot of you. Great. Okay, so storage spaces, it's a way that you can add cost-effective storage using commodity controllers. Since it's shared storage, you can also add that shared storage to CSV. So let's see how that's done. So the idea here is that you can add greater capacity to a cluster at lower cost. Let's see how that's done. Aha. Another opportunity for me to forget my password. There we go. Okay. Now, this cluster has some disks that are attached with a SAS bus. So when we look at storage, first let's have a look at the pools that are there. And you'll see that I have pre-created three pools. But we're going to go and create a pool right now, and we're going to create a storage space. and then we'll add that storage space to CSV. Now, while it's doing that, while it's enumerating the pools, so it seemed like a great idea at the time to use low-end hardware. Because then I could say, see, the new operating system, it works on your old hardware. If we have a look at the disk manager for this system, I just want to show you what's going on. So I just want to show you that here, what I have physically attached to this machine, I have 3 volumes, or three disks here. These disks are online. They're initialized, GPT initialized, but there's no volume on these disks. So these are raw. So let's go. Okay. All right, so you can see that we have the 3 pools here. Let's go ahead and say new pool, new storage pool. What should happen, the pool wizard should come up, and it should detect that raw storage on my disks. There we go. Okay, so let's create a pool. We are pretty creative here. And when you don't push the back button, it works great. So since I'm so creative, I'll call this pool 4. And yeah. All right. Now, it's successfully detected the raw storage. We're going to add the raw storage. We're just going to pull it up. So if all goes well, this will only take a few seconds. So there's pool 4. Now, once we have created a pool, now we're going to carve storage off of that. So we select the new pool. Then it's a right mouse click to say new virtual disk. Now what we're going to do here is we're going to build the disk, and then we're going to format it. We're going to put NTFS on there. So we are interested in carving out a disk out of pool 4. I completely forgot to mention the requirements for storage spaces. So SAS bus, you need to have at least 3 disks. The disks need to be 10 gigabytes or greater. But no, 4 gigabytes or greater. Okay. So let's call this storage space for TechEd Europe. There are 2 options here. You can create a simple space or a mirrored space. So the failover clustering does not yet support parity space, but simple or mirrored. So let's go ahead and create a mirrored space. How about let's create one for 4 gigabytes. And let's create it. Okay, the space is created. Now, let's put a volume. Let's format that space. There we go. You can see this is the space that we just created. We'll take the default. G, looks good. NTFS, let's create that way. Let's use that. I believe the alternative is REFS, but at the moment, CSV only supports NTFS. let's go ahead and create that. See, this is where I should have some music, I think, huh? Some Batman theme music or something. Okay, that completed well. So when we click on disks, we should see our new disk. It should be there. So disk 7, available storage, and it is in pool 4, and its name, it's on this storage space, and let's see if we can get this. That's fine. Yep. Okay, excellent. Now, again, let's see if we can add this to cluster shared volumes, and we can. So it'll take just a second to do that. Online pending, and there we go. And so now the new CSV file system is on that storage space. We can then do other operations, right? So we could then add BitLocker encryption to that storage space, et cetera, et cetera. One piece of feedback that we get, people often say, well, that's, it's really nice that we have a great name for this like cluster storage volume 4, but my users, they want something, a little bit more friendly, something that means something, that applies to their usage. So let's go ahead and just rename that. I'm going to open up the Windows Explorer, the File Explorer here. So on every node, there's going to be a directory called cluster storage. There's volume 4. Let's just rename it. So let's suppose that I want the finance department to use that volume. It's as simple as that. So you can give it logical names that are logical. Okay. Okay. So there you saw we created the storage pool, created the space, and then added the CSV file system to that space. Okay. Other improvements that we've made in Windows Server 2012 failover clustering. We have greatly improved our Active Directory integration. So first and most importantly, you can now create a cluster anywhere where you have permissions to in Active Directory. We used to default to the default computers OU, but now we create the cluster in the same OU that the nodes are in, the cluster nodes are in. If you have a restrictive AD environment and you want to be able to create the cluster in some other OU, we allow you to specify an LDAP distinguished name for the OU that you want to create the cluster in. So you can create it wherever you want. You can apply that LDAP, the LDAP distinguished name, either in the UI when you're creating the cluster, or of course in PowerShell at the command line. Another improvement that we've made is we have added support for what's called an Active Directory list, an AD list, cluster bootstrap, or a cold boot of the cluster when it can't see the domain controller. So many of our customers are coming to us and they're saying things like, hey, you know what? For this one application, we've virtualized the domain controller and it's actually running on the cluster. So when the whole cluster loses power, our data center loses power, we have a hard time when we're cold starting the cluster. In Server 2012, what we've done is we've enabled the cluster to cache credentials, so it will be able to handle a cold boot without visibility to the domain controller. So this is a great improvement for many, many of you. Also, we support much better support for branch offices, so that have a read-only domain controller or that have a domain controller that's in a DMZ. Node vote wait. So another improvement that we've made. Node vote wait is very important for some of you who want to manipulate the way that the cluster determines whether it's healthy or not. So especially for those of you running SQL Server who have a disaster recovery site and who have a manual, who do manual failover, this is a very important thing. I wanted to show you quickly where you can do this. Let's go back here. Hello. Aha. Well, that's fine. Let's go to the other cluster. All right. See, this is the advantage of having two clusters. High availability. Okay. All right, so right here in the Failover Cluster Manager, you can have a look under More Actions, Configure Cluster Quorum Settings. It's right here. This is our new quorum wizard. So it's designed to walk you through the quorum settings, the possibilities for your cluster. For those of you who want to do this, it's easy. You just select this third option here, the Advanced Quorum Configuration. Hit Next. And then if you want to select the nodes yourself, imagine you have a DR scenario where you have several nodes in a DR site. If you want to disable the vote for those nodes, it's just that easy. You can do it right there. But it's an advanced setting, and it's not like everyone will need to do this. Most of you will probably never need to adjust a node vote weight, but it's possible if you do. Okay. All right, next, dynamic quorum. Dynamic quorum is our new quorum model in Windows Server 2012. There's a great story behind this where we were working with a SQL Server customer who had a very tight budget, and he had a disaster recovery site. And he lived quite a ways from the disaster recovery site, and he had some connectivity issues there. And he didn't want to have to keep going to the disaster recovery site and manually configuring the quorum setting every time there was a failure. So he had a hard time getting his data center set up. And he was having to make several trips there to adjust the quorum settings. So we had a big talk with this guy. And he said, you know what? I want to achieve a last man standing effect. I have 3 servers on my primary site, and I want to be able to suffer sequential failures and still have the application running. And after talking with this guy, and we realized that this was an absolutely valid scenario, and it makes sense. The cluster's smart enough to know when there's a node down, and the cluster can simply recompute the quorum setting. So it was a relatively easy thing. So it's now the default setting in the cluster. So again, this will save you a lot of headaches. For those of you who know failover clustering for a long time, we recommend the setting. We think it's a great setting. We think it adds robust. It gives you some additional robustness to the cluster. Of course, you can configure it via UI or also in PowerShell. Okay, clustered scheduled tasks. We got a lot of feedback from people who wanted to do specific tasks, regular tasks to their cluster. And they had a hard time in 2008 R2. So they would go through a lot of trouble writing scripts and trying to make sure that things were running, on schedule on their cluster. So we took their feedback, and we have implemented clustered scheduled tasks. So the task scheduler is fully aware of the cluster. So you can create a scheduled tasks, and you can specify that you want it to run on every node on the cluster, on a specific node on the cluster by name, or on the node that holds the resource, a specific resource. This is all done by PowerShell, so you can specify it here with these commandlets. And for those of you who need it, we think that it'll be a big improvement for you. Node drain. This is big. So many of you came to us and said, hey, look, sometimes I have a single node that needs maintenance. I just want to add RAM to that node, or maybe that node needs to be rebooted because of a network driver change or something, right? So in 2008 R2, it was relatively painful to find the roles that were on the node and to move the roles off the node and then to evict the node from the cluster in order to do maintenance. And so when we took a look at the list and we saw that it's a pretty lengthy list, again, we said, look, this is something that the cluster's smart enough to do. Right? We can teach a cluster to do that. All right, let's try this again. Come on. All right. Now, what's my password? Now, if this doesn't work, that's fine. Okay, no problem. All right, what I want to show you is that on node 1 here, I have 4 VMs. Now, suppose I need to add RAM to node 1, or I need to reboot it for some reason. Node maintenance mode, also known as node drain, is a single click. So pause, drain roles. Now, what this does is it detects what role is on the node, and since these happen to be VMs, it's going to use live migration. So it's live migrating those 4 VMs off onto node 2, and it will then put my node into maintenance mode, and therefore I can then reboot the node, I can power it down, whatever I need to do to that node to do the maintenance, without affecting the cluster at all. So the cluster stays online, there's no issue with that. So okay, so we probably don't want to stay here and watch it drain the roles off the node, even though it is entertaining, I have to admit. You have to admit. It's pretty good. Okay, so who trusts me that this works? All right. Okay, good. So node maintenance mode, or node drain, is also the foundation for a new feature called cluster-aware updating. We talked to many of you, and you were telling us that it's a pain to patch a cluster. It's really a pain to apply the OS fixes on a cluster. So there's a new feature called cluster-aware updating. It comes with the cluster, with failover clustering. It's something that you have to enable. So cluster-aware updating, it can be a cluster role itself, or it can run outside of the cluster. So you can have a separate machine running cluster-aware updating and actually servicing multiple clusters if you want, or just a single cluster. Or it can actually run on inside as a cluster role. So the way it works is you configure a schedule. Then on schedule, it checks to see if there's updates. If there are updates, then it will use the node drain. It'll drain the roles off of the machine that needs to be patched. It'll patch the machine, reboot it if necessary, and then it'll fail the roles back over to that machine. It'll then move itself over to the other node, and then it'll operate on the other node in the cluster in sequence. So again, pretty easy. Let me just show you what that looks like. So here, so let's go to cluster 2. Another nice thing about having 2 clusters, again. All right. So let's go out. I know if I hover right here, there we go. Did I not click that right? Come on. Ah, there we go. Okay, so here we go. Cluster-aware updating. We just click on this. Yes, we want to run it. Now, it's very easy to configure. So in this case, we want it to look at cluster 2. So I'll just type that in, connect to my cluster. It detects that I've got 2 nodes in my cluster, and it also detects that I'm running on one of them. And so right here, I can just select this option, configure cluster self-updating options, and I can specify. So here it knows that I'm running on a cluster node itself, so I can add it as a role on the cluster. Here's the schedule. So daily, weekly, monthly patching. We can, there are a lot of options. It's very configurable. So we can pull updates from Windows Update or from the Windows Server Update service. So these are the update agent that ClusterWare Updating uses can use either of those sources. So, and there we go. So setting it up is really that easy. Okay, so that also greatly reduces the cost of running a ClusterWare Updating. Okay, so let's talk about the Hyper-V features that use the clustering infrastructure. So many changes here. One of the most important changes are priority. So VMs now have priority. High, medium, and low are your possibilities. So, and we also have the ability to preempt, in other words, to turn off low priority, medium priority VMs to keep the high priority VMs running. So I know this is important to many of you. Let's have a look and let's just show you how that works. Aha, another password opportunity. Okay, so let's cancel from here. Now, again, this is what I'm showing you. I'm going to my Windows 8 client machine, and I'm using the RSAT tools. I'm going to just launch the Failover Cluster Manager from here so I can get to my colleague's cluster. And we'll do some operations on his cluster. So, but really, I have good relationships with my colleagues. I just like rebooting their nodes. Okay, so here we can see that we have, my colleague has his 2 clusters, and I'm an administrator. Let's have a look. And so it's actually a second cluster here that's really interesting. Let's have a look at this node here. What's the situation? Okay, so I have 4 VMs running here, and then I have 2 VMs running here. So this is an interesting cluster because the alpha machine is much more powerful than the beta machine. The beta machine is intentionally low-end machine. You know, it's running only a couple of very low priority workloads. Alpha is running a bunch of workloads. So what we're going to do is we're going to reboot his machine. So let's just go ahead and restart that. Let's see what that looks like. So you can see what's happened. As we restart that machine just is offline at the moment. So as soon as we bring that machine offline, then the VMs start live migrating. So the cluster's smart enough to figure out that it has to bring the VMs over to the other cluster node. And now the cluster's trying to figure out how to keep the high priority VMs running and which of the other VMs it has to preempt. So priority is used in 2 ways. Priority is respected for start order, and it's respected on migration. So the high priority VMs are being migrated first, and the low priority VMs are going to be turned off here. Now remember, beta is a very weak machine, intentionally for this demo. And the whole point here is that the low priority VMs should be preempted. They should be turned off. Right? Many customers like this feature because it allows them to achieve greater utilization across their nodes. So by using the ability to specify high, medium, low, you can increase your utilization, and then you don't have to worry on node failover. The VM priorities are respected. Okay, so this will take a few minutes, but it will preempt the machines correctly. All right. So let's move on. Or do you guys want to watch that? We can. I might be buying a lot of lattes. So I know this is pretty exciting. It would be, a much quicker demo if I had a slightly stronger machine. I think you're right. Now, let's start it, because that's something that we would do. So one thing that we've improved in the UI is it should be telling us why it's failed. There should be information here that tells us what's going on. Also, we can go and look at the events to see what's going on here. Oh, okay. Oh, okay. Maybe there was an issue then. Okay. Well, sorry about that. I think I had a configuration issue there. Okay. Well, I hope you'll forgive that. Oh, well, maybe. No, there's an issue with that machine for some reason. I'm sorry about that. Okay. Let's move on. We'll try another variation of this in a minute. Okay, so live migration. So you saw that priority was respected and that there's preemption. Live migration, we've enabled queuing, and we've enabled concurrent live migration. By default, a cluster will allow 2 live migrations at a time. But you can configure that. If you feel you have enough bandwidth to enable more than 2 live migrations simultaneously, then it's just a configuration variable. It's a property of the cluster. So another thing that's greatly improved with live migration, our mobility story is much better. It used to be that you could only move a VM within a cluster. But with 2012, you can move a VM from a standalone server into a cluster. Of course, anywhere within the cluster, you can move it across clusters to another cluster, and of course, you can move it out back to a standalone server. Also, there's another live migration mode where you can achieve live migration with no shared storage, with shared nothing storage. So our mobility story is greatly improved in 2012. All right, so let's have another look. Just to tempt fate here, just to mix things up a little bit. Let's go to my other cluster. So, actually, I have a really good time with these clusters. So here we have a 2-node cluster. You can see I have a lot of VMs over here on node 1. Now, for some reason, what happens if I want to just select these 7 VMs here and move them over? So what I'm demonstrating here is basically a multi-select and then we're going to just move them. So we're going to say move, live migration, best possible node, and we're just going to move them off of this node. So this shows you the queuing effect, which actually you saw in the other demo as well. So this will show you queuing, and it'll show you that only 2 of these are live migrating at a given time. That is a good question, and it should. And I'm embarrassed, because I just told you that we respected the priority. Well, I think my clusters are feeling neglected, so they're maybe being disobedient. But seriously, that setting is respected. It could be an issue with the. So if we look at node 2, we'll see that it's going to start bringing in the Greendale clusters that were on the other machine. So the point is that this streamlines administration, and VM mobility is much easier now in Server 2012. You can multi-select. You don't have to move one at a time. You can just multi-select, go get a coffee, come back. The VMs are moved. In this case, also, this is a simple cluster. This is just a 2-node cluster on a. The placement is also NUMA aware, PNUMA aware, VNUMA aware, memory sensitive. So it will move it to the node that will be the best host for it. So it is quite clever about that. So again, more streamlining for administration. Okay, another improvement is VM storage mobility. It's possible to move the storage location of your VM while the VM is in use. So in this scenario, imagine that you're getting another SAN. A new SAN is being installed. As soon as you have connectivity to the new SAN or new storage, you can move the VHDs using VM storage migration and with 0 downtime. And it's fully cluster aware. Disaster recovery. A lot of you have been coming to us and talking about your need to achieve disaster recovery for your VMs. You have important VMs. You want to make sure that they're backed up. So we also provide an in-box disaster recovery solution called Hyper-V Replica. Replica provides a point-in-time recovery. So you can decide how much recovery time you want to have. You can specify that in the Hyper-V Replica settings. You can specify it, and Replica will take snapshots, point in time, and move them over to your DR site. So that's seamless. It works with all your HA VMs, and it works while they're in use. I want to talk a little bit about guest clustering. Many of you use guest clustering. That is, you have host machines, you have VMs running on those host machines, and then you form a cluster across your VMs. So we've supported guest clustering for a long time, but in 2008 R2, the only storage option that we supported was iSCSI. So in Windows Server 2012, we heard that a lot of you have deep investments in fiber channel storage topologies. And so we've enabled a virtual fiber channel adapter that allows your guest VMs to use your fiber channel storage. So again, this is enabled in 2012, and it's simply present. And of course, it'll work with your clustered VMs. VM monitoring is a new feature in Windows Server 2012. A lot of our customers were telling us that guest clustering is interesting. It provides a lot of mobility for them. But what they really were after was some kind of lightweight mechanism to achieve the health monitoring of the application. And they wanted just a lighter weight mechanism to improve the handling of their applications that were running in the VMs. So what this means is that the cluster service running on the host machine can actually look at events that are occurring on the VM. And it can be, you can inform the cluster that when certain events are seen, then you want the cluster to restart the VM or move the VM or perform some manipulation on the VM when you see certain events. So for those of you running SQL Server or other workloads in a VM, this will be an important facility for some of you. PowerShell integration. So I've spent a lot of time focusing on the UI and how to do things from the UI and show you all, how easy things are from the UI. Everything that can be done from the UI can be done with PowerShell. So, there are a large number of Hyper-V commands, a large number of clustering commands. They work very well together. So for those of you who do a lot of automation using PowerShell, so how many of you do automation using PowerShell? So, okay. So for those of you who raise your hand, all of these features will be interesting. So we worked hard to conform to all the rules and to make sure that you can fully manage the life cycle of your cluster and the applications running on them through PowerShell. So yeah, live migration, for example, is as simple as this. You just, you can get the VMs by name. The objects can be pushed through the PowerShell pipeline to move cluster virtual machine role. So it's really quite simple to do. One thing my colleagues in Hyper-V want me to mention is that Hyper-V is now much more aware of where your storage is, and that there are fewer points in time where you have to go into Hyper-V and configure storage, right? Storage settings. So that's greatly reduced, right? In other words, so much of that manipulation that you had to do in 2008 R2, it's simply not needed anymore. For those of you who are using third-party storage, they have a switch on their update cluster virtual machine configuration command to allow unverified paths, basically any third-party storage that you want to use. If Hyper-V issues a warning, you can just use this switch and simply move straight over it. Okay. We've covered a lot of material. So in summary, when you think about everything that we're doing here in Server 2012, we're really providing a huge amount of value for you. We're enabling you to do a lot with your private cloud deployments. So when you think about CSV2, asymmetric storage, the continuously available scale-out file server, when you think about things like dynamic quorum, the ability to adjust node weights in the UI, node drain, right? The ability to BitLocker CSV, all the PowerShell integration that's there. When you think about your live migration options that you now have, so moving VMs while they're being used from standalone servers to cluster servers, across a cluster to another cluster, and then out to standalone machines. When you start thinking about the new life cycles that are possible, storage migration, the guest clustering improvements with the virtual fiber channel adapter, the VM monitoring capabilities that we now have, clustered scheduled tasks. When you put it all together, it's a lot of value. It's a lot of high availability at a better price point. It's more flexible, and it's easier to run. So when you add it up, it makes a lot of sense. So I hope you enjoy using it. I hope you now feel that you can get your hands on it, that you can do it yourself. I hope I can convince you that if I can do it, you can do it. So, and I'd like to wrap it up right there. So thank you very much for coming to my session. I really appreciate that.